Greetings to you all. In this video we're going to be looking at orthographic projection. It was introduced last time when we had a meeting on Friday, but I thought we need to find time to kind of speed up the pace at which we should be moving. So in this video we'll get to learn what isometric projection is, the isometric drawing. The main focus is being able to look at an isometric drawing that is simple and then draw the correct orthographic drawing. So it's basically about interpreting isometric drawing into orthographic drawing. If you can remember well, we said an isometric drawing is that drawing that looks like how an object will look like if it's in a picture, while orthographic is the type of drawing which involves you drawing certain parts of the drawing. But we will do all the definitions once more in case some people never attended the first meeting. So an isometric drawing is basically a method of graphic representation of three-dimensional objects. Most of the objects we deal with in real life are three-dimensional objects. They can be described using three distances. The best way to kind of imagine what three-dimension means is calculations that you've been doing in mathematics. You've got area calculations. For you to find area, you need at least two distances that are maybe perpendicular to each other. Let's say you want to find the area of a rectangle. You need the length and the breadth. So you're using two dimensions or two distances. Now, if you start doing volume calculations, most of the times you need three distances. So when an object can be described using three distances, then it's a three-dimensional object. As you can see in the pictures that are shown on screen right now, we've got this object here. It's a three-dimensional object. We've got a length here, 70, a breadth, 52, and 100, which is the height. So for isometric drawings, you'll be able to see at least three distances that are perpendicular to each other. Most of the other features, there will also be a similar way in which you could describe them. But we're not going to start with such complex drawings. We're going to start with much simpler ones. Isometric drawing is very important in presentation of designs. For example, this first drawing is a bracket, this other one is a housing. So once a drawing is made like this, manufacturers of different components, they can be machine components, they can be electronic components, anyone can design the required artifact or the required object that needs to be made, provided that they've been given these drawings. So isometric drawing is something that's very important when it comes to designing in engineering. Now, this isometric drawing does not show all the detail. For example, here they tell us we've got two holes. Of course, because they've said it's a hole, we know it's going to be a through hole. Another way of drawing, which is known as the orthographic, enables us to view just certain parts of our drawing. For example, we could only view the top part of this drawing, or we can only view the object via the arrow A, and then we'll begin seeing certain features that are shown here but in a better way. For example, if you look in the direction of arrow A, you're not really able to see that this part here is slanting. You just see a straight line. But if you look in this direction where we've got the 52, you can see that this is a slant. Similarly, for this object, which is a housing, if let's say it's closed up here, you won't be able to know the interior of this object. You won't know that this part is a corner, and so there is need of another way in which we can represent drawings. Isometric drawings are very good to make us able to understand how the object looks visually, because we see in three dimensions. However, when we need to actually design, we need to convert this isometric into an orthographic, and that's the goal of this video. Now, a key thing that I always like talking about is how these names really apply to things that are properties of these drawings. For example, in the word isometric, you see that there's this first part which means ISO. Whenever you see ISO in drawing, it just means there's some things that are equal. For example, we have the isosceles triangle. If you hear ISO, it's in the isosceles triangle, it means two sides are equal. Now for isometric, the ISO in isometric just means that the principal axes are 100 degrees apart. If you attended the first meeting, you obviously heard me not talking about this 120. Instead, I like talking about the 30 degrees because it's the much more useful angle. So in that lecture or in that tutorial, I talked about two angles that are always equal that are used to get the isometric axes. A 30 degree on the right, as you can see in this drawing, and a 30 degree on the left. It's rare that we are going to be using 120 degrees to draw our isometric axis. So the first procedure when drawing these isometric drawings is having a baseline like that. Then we draw a line that is at 30 degrees from this baseline, which is horizontal, on the left to get the left isometric axis, and on the right to get the right isometric axis. To get the isometric axis that's here, we just draw a line that is perpendicular to this base. But in actual sense, the isometric is coming from the fact that these axes that we are using to draw our object so that it looks like it's 3 dimensions on the paper are going to be 120 degrees apart. This is 120, this is 120, and this is also 120. However, I refrain from using this 120 because most of the times it's these two angles, the 30 degrees and the 30 degrees, which are mostly used. So without wasting much of your time, let's get into how we interpret isometric drawings. There are two methods. The first one is first angle projection, and the other one is third angle projection. In these two methods, we're still drawing the same kinds of parts of the object. However, the order in which we draw them is going to differ. A picture here is gotten from a very useful book where we've got a plan, a front, and an end. So what is the plan? The plan is the view that you see in an object when you look at the top of the object. So if you've got a phone nearby when you're watching this video, it's like putting your phone on the table, then looking at the top. Obviously you see the screen. Then if you look at the front, you usually look at the longer side of your phone, so it's that side view, the longer part. Obviously the side where you have buttons, and then the end can be the part where you have your charging port and things like that. Now, the plan, the front, and the end are always the views we're going to be drawing in orthographic projection. The difference in first angle projection and third angle projection is how we order the plan, the front, and the end. In this picture here, you've been shown both of the types of projections. We've got first angle projection, and then we've got third angle projection. In first angle projection, what happens is the plan is always drawn below the front elevation. These are rules that I talked about and rules that I'm again emphasizing. Then the next thing, the views are always projected as shown. What do they mean by the views are always projected as shown? For example, if we have F here, if you look at this arrow F, it's pointing from the left to the right. Another way you could think of is that the drawing is on the right part of this arrow, and then for the end, the drawing is on the left part of this arrow. For the plan, you could also do something similar. The plan, if you put an arrow at the top here, the arrow is going to be pointing downwards, and the drawing will be below the arrow for the plan. So what they mean by the views are always projected as shown. In the front of the arrows E and F, it's simply the direction in which your arrow is pointing is where your drawing of that particular view is going to be. So the front here in first angle projection is pointing towards the right. So our front view is going to be on the right part of all the three views. As you can see here, our front is on the right part. If you say this is the right, then this is the left part, you can truly see that the front is on the right part. The end is on the left part because in first angle projection we are following the direction in which the arrow is pointing. This arrow E is pointing towards the left. Even though it's kind of at an angle, it's pointing towards the left, you can agree. So our end is going to be on our left. The plan is pointing, the arrow for the plan, even though it's not there, you can agree with me, it's pointing downwards. And that's why our plan is below the front. So those two things, where you're going to position your front, your end, using these arrows, are very key things. If you just understand that, you can understand first angle projection. The next thing you realize is this symbol here. I will speak more about it when we meet physically, but this here just agrees with this description that we've given. This is our front. There's a front view here, and then there's an end view of this telescope. In the third angle projection, we kind of reverse things. Here we said the plan is drawn below. For third angle, the plan is going to be drawn above. And then when positioning our front and our end, we're going to take the direction opposite to the direction in which the arrow is pointing. Here we've got our front view. This arrow for F is pointing towards the right. But if you look at our orthographic drawing of this drawing here, you can see that our front is on the left. So if the arrow is pointing in the right direction, your view of the front is going to be in the opposite direction. The opposite of right is left. So this is why our front is on the left part. The same applies for the end. The end is pointing towards the left, but our view is in the opposite direction of left, which is right. Once more, here there's a projection symbol that you need to understand. More of that will be explained when we meet physically. So this here is the two methods in which we can interpret an isometric drawing. We've got a front, an end, and a plan. These principles are much understood if you do some practice and you see the drawings being made. So in the last remaining minutes of this video, we're going to do some practice. We're going to start with first angle projection, and we're going to be drawing some of these. We've got 4 drawings, A, B, C, and D, and we're going to take the shaded part in blue as our front. I'm going to do A, B, and then try doing C and D. So here we have our drawing for A. If we take this first part here to be our front, we can say that in this direction we've got our front, then in this direction we've got our end. We can also put an arrow at the top here to mean our plan. So for our front view, because we're introducing this concept, we've got these shaded parts. So we've got this part here, this one here, this one here, and this one. For starters, it's good that we label these corners so that they don't get confused. So here we've labeled A, B, C, D, E, F, G, H. We've got I here, we've got J, K, we've got L, M, N is this point, O, P, Q, R, S, and T is the corner there. So if we're trying to draw our front, the first thing we need to realize is the arrows. Where is the arrow for F pointing? It's pointing towards the right. So our front is going to be somewhere like that. This is going to be our front. Then our end, you can see the end is pointing towards the left. So our end is going to be on the left of the front, like that. And then our plan is going to be below the front. So here, this is just kind of a schematic way of drawing our actual views. So we've got a front here, an end, and a plan. Now, what will these views actually be? So after we know the front is on our right, the end is on the left of the front, and the plan is below the front, now we can start drawing what we can actually see. So for our front, what we're going to be seeing is the blue parts. So we're going to be doing some assumptions this time because we don't want to work with distances. We've got AB, FG, which is a shaded part. You can say it's a corner like that. And then we also have the part LMPQ. If you can agree with me, you start seeing that F and L are joined by a line. If you were to look at the object, if this was kind of L-shaped, F and L, if you look in the front, are joined by the same line, which will be kind of at this point here. FL, F will be at this point, and L will also be in the same line. So we can say this is A, this is B, this is F, and then at the back of F we have L, then we also have G. At the back of G we have H. So if we go upwards, we're going towards P. So if we go upwards like that, this point here is P. If we go towards our right, sorry, we're going to be going towards Q. And then if we come down like that, we're going to be going towards M. So we'll have a drawing like that. If we complete it. So this is AB, our C is at the back of B, then our D is the point here, we've got an E, we've got J at this point, we've got K at that point, also got Q. So this here is our front view. These are the shaded parts. If we say this is 1, this is going to be 1. If we say this part is part 2, this here is part 2. If we say this part is part 3, this is 3, and then this is part 4. So all our parts are there. So here I've just drawn it, and then this is how our front will look like. Now let's look at our end. Our end is the part that involves KN, point O, point E. Then we also have QS, M, and T. So we're looking at this view, and then we're going to draw only the parts we're able to see. So we're going to have the part KE like that, another one like that. Then you can see we've got this other part that's going up like that. So this is KN. KN is the part from here to there. This is KN. We've got EO, E and O. Then T is this point here. This is T. M is the point behind N. So at this, the furthest point we can see is N, but we also have M at this point. Then on top here we've got Q and S. Now we do the same for the plan. So to draw the plan, we'll start with RS. So we'll draw RS like this, and then you can see we've got this PR. So if this is R and S, PR will come this side. Then we also have SQ. Then we'll have a line of PQ that will be here. And then from there we'll have this distance FL, which is a big distance if you compare to PR, which is going to be drawn like that. Then you see that LT is longer than PQ. So if we draw LT, it will kind of protrude like that. and then to complete we need FG like that, then a GH that goes inside HI, which will go towards this end, and then we'll complete. This is roughly how our plan is going to look like. So we've got RS at the top, we also have L and M, we've got N, we've got F at the top, we've got G, we've got J and K. If you quickly notice, there were some letters that are not being shown in some other drawings. Here I've just quickly filled out all the other letters. For example, if you look at the front, in the front we can only see point A, point B, F, G. We can also see J, K, D, E, and then we can also see P and Q. What you notice is that when we look in the direction of F, we're only going to draw the points that we first see as we move in this direction. So as we are moving from this point until we reach the end, you can see that B is before C. So B is going to be a point we'll see that will be on our front. The same as G. G is before H, so you can't see the H here, it's behind the G. The same as the L, we only see point F because we're looking in the direction of this F here. We don't see point N because when we look in this direction, K is coming before N. For this other part, you can see P is coming before R for this part that's here. The same applies for all the other views. When you look in direction E, E is coming before D, K is coming before J, N is coming before M. This is why you can't see M here. We've got O, which I forgot to indicate. O is a point here. Then we've got T, Q, S. In our plan, you can also see some letters are not present. We can see we're not supposed to see L, we're supposed to see P here. R, we're supposed to see Q and not M, because if we look from the top going down, Q is coming before M, S is at the top, R just like that, F, G, we've got J, K and N. These letters here are just there to help you refer to the points a bit better. In actual drawing, you're not going to refer to points like we're doing here. Provided that it's the first time we're doing it, I'm just using these points so that it can be easier for you to know which point I'm referring to. Now let's look at B. For B again, we will notice that our front is going to be in the direction such that the blue shaded part is our F. So in this direction, we've got F in this direction, E in this direction, and then our plan is at the top like that. So F is the direction of our front, E and P are respectively the direction of our end and our plan. If you see, the arrow direction hasn't changed. Our front is still going to be in our right part, our end is going to be on the left of the front, and then our plan is going to be below our front. This is because we're using first angle projection. So we can draw the places where our front is going to be just for this sketch. So this is going to be where our front is going to be. Then our end is going to be somewhere here. Our plan is going to be like that. So you can see our front here is on the right, our end is on the left of the front, and then our plan is below our front. So in first angle, we've done the correct thing. The next thing is trying to draw this. If you see, we've got this edge here. It's going to be this part. Then we've got this edge that is here. It's going to be at the bottom like that. It also has a part on the top like that. Then we also have this blue shaded part. It's going to continue like that. Then we also have this edge here. Which is somewhere here. Then we have this other blue shaded part that looks like this. So we'll draw it at the top of this drawing to look something like this. One thing you notice is we have all the shapes of that have been shaded. For example, this blue shape here is this one here. This blue shape here is the one that's drawn here, and then this blue shape is the one that has been drawn here. When drawing our end, it will be like we're drawing these parts that I'm going to draw with some hatches like that. The parts here are going to be the shapes we'll be drawing in our end view. So if we draw these three shapes together, we'll have our end view. So our end view will have a shape that looks like a square, like this. Then this other one here, you can see it's like that, and it goes up a bit. Then we have another shape that's at the top here. Then now we're going to draw our plan, which are these parts that are not shaded. We've got this shape, and this shape. If we draw them together, we're going to have a result like this. And then another shape that is here. Then we draw the last remaining shape, which looks like this. And our drawing is done. So this is our front, our end, our plan. When starting to draw these concepts, it's very important that you can even use this concept of shading. When you have an F pointing like that, you recognize the shapes that will be part of your front. This one, and that one. Then you also shade your parts that will be the end. Once you do this multiple times, you won't even need to shade. You'll be able to just visualize which parts are your front, your end. Now, in the remaining few minutes, like 2 or 3, let's see how we could draw in third angle projection. We drew the object in A and B using first angle projection. Now we're going to be drawing some other objects in third angle projection. If you can remember, I said CD, try to do that, and then follow the same principles we've used for A and B, and then get the first angle projection of the front, end, and plan for C and D. Hopefully, come with these small papers in the next class we'll have, and that will show you're putting some effort and something has been learned. Now, we're going to be using different figures for our third angle projection. We're going to be using E and F. GH are also going to be your simple exercise that you need to carry out. So how can we draw E and F in third angle projection? If you can remember, we said for third angle projection we'll be doing the opposite. The front is going to be below the plan, or if you can remember from the previous slide that we had, these are the rules just to help you remember. The plan is above, then the direction of the arrows here are going to be the opposite direction in which we draw our views. So if our arrow is pointing towards the right, our front is going to be in the left. If our arrow is pointing towards the left for our end, then our end is going to be in the right, and you can see that is shown in this diagram. So nothing will change much in the way we will draw our arrows and everything. What will mainly change is the order in which we would place our front, the end view, which is in this direction, and the plan. So this time we're using third angle projection. The first thing we need to know is our front. Our front is shown by these blue parts. This is what we are going to be drawing in our front. This square-like shape, this rectangular one, the square, and then the rectangular one. These are the three parts that will make our front. Now we need to decide where it's going to be. In third angle projection, we get the opposite direction of the front. The front is pointing towards the right, this arrow here. So if it's pointing in the right, we're going to get the opposite direction. Our front is going to be in the left. And now we position it in this part. You'll see why very soon. Then our end is going to be on the right part of our front. Then we said our plan is going to be above the front. So like that, we have our plan, our front, and our end. Very simple, like you can see. The most important thing is knowing where your front will be. In third angle projection, our front is going to be in the opposite direction of the arrow. Our arrow is pointing in the right, so our front is going to be on the left. The arrow for the end is pointing towards the left. We get the opposite direction, which is right, and you can see our end is on the right part of the front. Now let's fill in what we can see in our front view, end view, and plan. For our front view, I earlier said we'll have this kind of square shape, and then a rectangular shape, another square shape, then we'll have a rectangular piece which looks like this. For our end, we'll have just an L-shaped object like this. Like that. Then for our plan, we're going to start with this top edge, the one here. So we'll have a part like that. So we're drawing this space and this one here. That would be our plan. Got a small rectangle like that, and then we've got this shape here. And we're done. The only thing that might remain is outlining. This would what our final drawings for the sketches would look like. Let's quickly look at F and see how it will look like. Before we begin to draw, it's a good idea that you know where your front is pointing. The arrow for your front is pointing that. For your end, it's pointing like this. Then for your plan, it's pointing like that. After you know the direction of your arrows, you now can draw the front, end, and plan using third angle projection. Since the arrow for our front is pointing towards the right, we're going to get the opposite of right, which is left, and take that as the position of where our front is going to be. So we'll draw it in the left part of our drawing, like that. Then our end, you can see the arrow for the end E. Here E is representing the end. It's pointing in the left direction, so our end is going to be in the opposite of left, which is right. This is where it's going to be the right of our front view. So this is F, this is E, then our plan is going to be above our front. You can see even the arrow there is pointing down. If we use the principles that we've used to locate our front and our end, you can see that we're taking the opposite of down, which is up. So we have P, F, and E. Now we're going to draw these parts shaded in blue. These shapes are our front part. You can see we have got a shape that looks like this. Another one, though it's not full, you can assume it looks like that. And then the other one like that. Then there's this blue shaded part, which simply looks like this. Not something difficult. Then we have our end. Our end is going to involve these parts here only. You can see it's just this L shape, like that. We have our end. Our plan is going to involve this part here, here, and there. So we'll have a top part that looks like this, like that. Okay, now we can outline this and then we can have a better sketch. And this is our final result. Here I'm trying to get rid of all the unnecessary information that is used when drawing these orthographic projections. I'm trying to emphasize on mainly the idea that we use to draw orthographic projections. There's much more to drawing this that is helping me draw my views, and we'll discuss all that as we meet physical. Thanks for watching till the end, and make sure you understand everything that has been discussed in this video, as we're going to build up from the knowledge that has been discussed.